Hello all. Today we're going to be looking at a few of the built-in features of the Java language. And by built-in I mean Java comes with a number of classes or templates that contain some functionality that we can use even though we didn't write it ourselves. So that ends up being very convenient for us because we may not know exactly what we're looking for, or may not know that something is useful, or may not in fact know how to implement it, but know what it's used for. And if that's already written for us, it saves us a lot of time and effort. So the first class that we're going to be looking at is the math class. And this has a bunch of functionality from doing trig functions to rounding numbers to absolute value and exponent equations. So let's do a new class, a new Java file. Call it Math Examples. So here we're going to practice a little with using an external class. So you'll notice I'm again making my main method, which is where we're going to be writing our things. So to start out, I'm going to start with a very basic print statement. And inside I'm going to print a value, let's say 8.6. You can see it'll print out. Let's say instead I want to print a negative number. Okay, that's great. It'll print out that it's negative. What if I want to take the absolute value of this number? Well, we know that it's 8.6, but the computer doesn't. So I have to tell the computer to print out the absolute value by, well, I'd have to come up with some complicated method of figuring that out. And it turns out it's already written for us. So the way I'd access that information or that functionality is by using something called the math class. This is pre-written, and we know it's a class because it starts with the first letter being capitalized. Now to look inside, I have to do a dot. This dot notation lets me look inside for the absolute value function. And inside the absolute value function, inside those parentheses, I'm going to put an argument. And that argument, or that parameter, is this 8.6. So this entire thing right here should print out the absolute value of negative 8.6. Let's see what it is. It indeed prints out 8.6. So it seems relatively trivial, absolute values. When might I use those? Well, there are a lot of instances where they might be useful. But to start out, just knowing that we have the option to use some of this built-in functionality is helpful. Let's think of something a little more useful. Let's say instead of Math.abs, let's look at Math.round. This should round things up or down to the nearest integer value, or the nearest whole number. So in this case, we round 8.6 and we get 9. And notice it prints out as an integer. What if I do something a little different? Let's say 8.4. This should round to 8. That's great because integer division, if I said 8 divided by 3, well, that doesn't round, that cuts off the end. So that'll give us 2. But if I do this with doubles, it becomes somewhat useful. I end up getting 8.0 divided by 3. I get 3 because it rounds up. So there is a difference between doing integer division and doing the rounding. It'll obviously do this part inside first. Then it'll apply the round function, and then it'll print it out. Okay, now let's look at another thing we can do with math. Let's say we want to find the minimum of 2 values. So the way we do that is we look inside math, dot, tells us to look inside, and we're looking for the min function. And the min function, we'll mouse over and we see that it says we have to have an integer and an integer to compare. So let's say I want to, and this would work for doubles as well, but the standard one that comes up with first is integer. So let's say I want to compare 8 and 9, and let's see what prints out. It'll print the lower value, 8, of the two values 8 and 9. Now this seems obviously trivial, but what if I were to do this with variables? Okay, well, what if I want to compare num1 with num2? So I have two variables, two integers. One has the value 15, one has the value 20, and we're going to compare. And it'll print out 15. What if I switch this, though? What if I put num2 first, num1 second? Take a minute to think about it. And it still prints out 15. It doesn't matter which one goes where, it'll just print out the smaller value. I could also do max to find the maximum value between two numbers. For instance, this time it'll print 20. This is especially useful when you don't know what a variable is holding. For instance, I could get user input here and user input here, and it wouldn't know necessarily which value is bigger, or we wouldn't know, but the computer does, and it's a really convenient way to print out the bigger number. Otherwise, we have to create a slightly long chain of math. Now, what else can we do? We can do something called POW. And what does POW do? POW returns the value of the first argument raised to the power of the second argument. So the first argument is our base, num1, let's say, raised to the power of our second argument, num2. And first I'm going to change these to doubles so that we can have some slightly more interesting answers. And let's run this. 3.325256730096506E23. So if you have ever seen a calculator, you may notice that this means raised to, or multiplied by 10 to the 23rd power. In fact, this is very close to Avogadro's number, in fact. But let's change to slightly smaller numbers. So let's say I want to raise 10 to the second power. Well, we know that should be about 100. And we run the Math.PI and it prints out 100. 10 to the third would be 1,000. And I could also type this in here, 10 and 3, 10, base 10 to the third power should give me 1,000. Let's say 12 to the third power, it ends up giving me 1,728. And so you can see that this is a really easy way to get exponents out there to raise things to powers. That's also functionality in the math class. What if I want to find the tangent? So let's see tangent. Maybe the tangent of an angle, 84 degrees. The tangent of 84 degrees is negative 1.07. And the important thing to notice about this is that we have, this can be a double argument. So let's say 30, let's say something like sine of 20, let's say something easy, 60, no, 30. Sine of 30 should be negative 0.9. So what this is doing is talking about radians. So let's think about, let's see, oh, maybe we should start to use the value for pi. How do we find pi? Pi is what? 3.141, 59265358 9, you know. So it goes on and on and on. And that seems like something that That should already exist, so I don't have to type it out all the time. In fact, it does. So to get pi, I can just type Math.pi. And notice this is in blue, it's a constant value. And it's listed as this value in the math class. So let's run this. And we get something really, really small. Let's say we have an angle in radians, so pi radians, the sine of that should be really, really small. And this runs into an error that we get when we get a double that's trying to get really, really close to 0. Let's look at something like pi over 4, or pi over 3. No, pi over 6. Pi over 6 should be good. So if you know your trig identity, or your trig your unit circle, this should make a little sense. We should get about 0.5. Notice it's not exactly 0.5, and this runs into some of the limitations of doubles and how they store information. Sometimes you're not going to get something exact, and this is where rounding can become somewhat useful. So pi over 6 gives us that. Pi over 3 should give us square root of 3 over 2. Pi over 2 should give us 1, because that's our maximum, and that makes perfect sense. So the math function for sine, cosine, and tangent give us values based on radians. Again, we get e to the 16, so we're getting values that are way too big or way too small because of how doubles end up working on the back end. So with very large or very small numbers, we can get some, or things that go with decimals that are really close but not quite to a tenth or a hundredth or a thousandth. We can get some rounding errors with our doubles. But in this case, math has a tangent function, maybe it has a cosine function. This should give us 0, and it gets close to 0, but not exactly. Let's say pi over 3, again, this should give us about 0.5. And again, we get that rounding error. So this is something to be cautious with a little bit, and we'll talk about how to handle this rounding error a little later. But know that we do have Math.pi, and again, if I remove this, I should get 1, -1. And we also have Math.cosine, Math.sin, Math.floor. Floor cuts off the remainder. We'll print out 3.0 for pi. And there are a number of other functions that you should look up in the Java API. But for now, this is just a quick demo of the math class, and play around with it and learn a little more.